It's Mr. Woodward showing you in this video how to use Vernier's video analysis app. So I'm going to start up here and go to videoanalysis.app, and I'm going to get their starting screen. And you're going to import your own video that you're going to take in the classroom, but I'm just going to use one of their sample videos to show you how this works. So let's start with this basketball shot sample video. And the first thing that you want to do is to track the motion of the object. So first of all, I'm just going to play this, and this is a video of a guy shooting a basketball at probably his school campus. And so I'm going to, bring the video back to the beginning. And first of all, I'm going to show you that this software can actually track the motion of the object. So instead of adding individual points like this, and sort of having the object advance forward one at a time, right, which can be tedious, there is a way to have the software automatically track the object. So first of all, I got to delete these points. So I click Edit, and then I can just take each point and drag it into the trash and get rid of all those points. And there's probably a faster way to do this. I don't know what it is yet. I'll let you know when I figure it out. But after getting rid of these points, and see, there's a stray point right there. That's gonna mess me up later. Get rid of these points. These ones were stacked on top of each other. I'm going to try to auto track. So here we go, coming backwards. So you want to start with the object airborne. So like this would be too soon, right? Ball is still in the guy's hand, fast going forward a frame, like right there. So I want to start tracking from here. I'm going to click track. And then I'm going to bring the tracker over the ball. I'm going to reduce the size of the tracking window to the ball, and I'm telling the software to track those orange pixels. And then up here, I'm going to click Start Auto Tracking, and it's just going to follow those orange pixels across the screen, playing the video all the way through until the end. And at the end, I think it will like automatically lose the ball or something. So this is really great because it adds the points for me, and I don't have to do all this tedious work. So I'm going to wait until it loses the ball or stops tracking automatically, and we'll see what happens here. Great, it says down here, object lost, reposition the cursor and track again. So that's great. All right, now that I've tracked the object, I need to tell the software where the origin is and what scale we're looking at. So I'm going to click System over here on the left side. This video conveniently placed a meter stick in the bottom on the sidewalk to give me a sense of scale. So I'm going to remove the graph and remove the data table so I can zoom in on this video. And I'm going to bring these scale markers to the two sides of this meter stick, where I'm now telling the software up here that 236 pixels is equal to 1 meter. Okay. By the way, if you don't have a meter stick in your shot, or you have like 2 meters or some other object in your video, you are also welcome to use that for scaling. For example, let's say that you know the exact height of this guy. You can just bring the the scale markers across his height, right? And then from there say that he is, I'm just making this up, like 1.86 meters or something. And that would be another way of scaling it. But let's use the meter stick here. And then I'm telling it that that is equal to 1 meter. Okay, now we need the origin. We're going to set the origin, meaning the initial position at the ball's first position after it leaves the guy's hand. In other words, where my first dot was, right? So if I go back over like to the add window, that's where my first dot was. And then I started adding dots after that. So I'm going to go back to that where that first dot was, grab my origin marker here and bring it over that. It was at the center of the ball. Okay, I've got my origin, I've got my scale, I've got my points. Now I'm ready to take a look at some graphs. So I'm going to switch on the graphs. And actually, I'm going to exclusively focus on the graphs, getting rid of the video now. So I would love to be able to see two graphs. The graphs on the top are position graphs. In blue, you have the vertical position. In red, you have the horizontal position. And then on the bottom are velocity graphs. In blue, you have the vertical velocity. In red, you have the horizontal velocity. Let's just do a little zoom out to make sure that I've got all my data in place, which looks good. And then for the purposes of this video, I am just going to focus on the ball's vertical motion. So I'm going to switch off all the horizontal data. So switching off the horizontal position, switching off the horizontal velocity, and then it might help me again to zoom to all data in this new view by clicking this magnifying glass. Okay. Finally, what if I wanted to know like some specific details about this ball's motion, like what was its initial velocity when the ball left the shooter's hand? Well, the initial velocity would be like this point right here, right? Because that's the first velocity in the graph, and this means that the ball left the shooter's hand at 5.52 meters per second. What if I wanted to know how high the ball went at its maximum height? Well, now I'd be looking at this top graph, which is right the y position, the height over time. And so I could just sort of click on these and say, okay, well, the ball's height there was 1.58 meters. The ball's height here was 1.591. The ball's height here was 1.603. That seems to be the highest one. I could like click left to see if that one's any higher. Doesn't seem like it is. So that would be the ball's maximum height. Okay. And then right below it, I can actually check and see what the ball's velocity was at its maximum height. You can see that the velocity is approximately equal to 0, negative 0.04 meters per second. Okay, the last thing you could do is you could find the equation of these two lines, and the equation of those lines could give you all sorts of other information. Specifically, the slope of those lines can be very useful. So I'm going to focus on this one down here, and I'm going to add a best fit curve, a curve fit to this set of data. And this looks very straight as it is, so I'm going to go with linear. I could change it up if I didn't think it was a linear fit, quadratic, power, inverse, inverse, square. This looks pretty darn linear, and I'm going to hit apply. Okay, so now down here, I have the equation of this line in the form y equals mx plus b. And notice that I have the slope, right, the m value. And the slope of this line is negative 9.486. And that slope, right, maybe go back. Remember, the slope of a line is the rise over the run. The rise of this graph is vertical velocity. The run is the time. So what do you get when you have vertical velocity divided by time? Well, the velocity divided by the time is the acceleration. So the slope of this line represents that basketball's acceleration in the vertical direction as it's rising and falling under the influence of gravity. So this ball's acceleration, vertical acceleration, is negative 9.486. And if we did a little bit more digging, we would find out that it was in meters per second squared. So that's a big survey of how to use Vernier video analysis to track the motion of an object, to generate some graphs, and then to do a little bit more analysis of those graphs and the information that they give you.